Hello there, and then welcome to a brand new lesson. This is How Beyond Numbers, where we learn maths the easy way. In our previous lesson, we looked at the divisibility rules for 2 through to 6. This time around, we are looking at that of 7, 8, 9, 10, and 11. You can visit the other or the previous video if you haven't, just to learn them and then stay updated. Let's quickly go into that of 7. So the rule for 7 says that we should do what? Double the last digit of the number. Before we even double, let me write something. So here are the steps. Before we determine that the number is divisible by 7, we need to first of all separate the last digit. Okay. So whilst we are doing it, let me take a number so we actually have a feel of what this rule is talking about. So if we have a number such as 672. So what this rule is saying is that we should separate the last digit. So that instead of 672, I'm going to rewrite it as 67 and then 2. You see, so I've been able to separate, and then I have 2 digits now. Now, what it says is let's double the last digit of the number. We have to double the last digit. In this case, this here is the last digit. We have separated it. So let's double it. So if you have to double this last digit, it simply means let's multiply it by 2, and that gives us an answer of 4. Now this 4 we have gotten. The next step says let's subtract the double value from the remaining digit. From the remaining digit, it means this particular one. After we took out the 2, after we separated, this is the remaining digit. Now that we have doubled 2, we have 4. Let's take out 4 out of this remaining digit. So that is 67 minus 4. You see, 67 minus 4. And if you have to subtract, you have 7 minus 4, which gives us what? A 3. Then 6 minus nothing, we still have our 6 over here. So this here is our answer. Now, after our subtraction, the answer or the rule says if the result is 7, if the result is 0 or a multiple of 7, then we can say that this original number is divisible by 7. So the question we now need to ask ourselves is this answer we have here, is it a multiple of 7? You see, so if you are good with your multiples, fine. You can easily say, yes, 6 times what? 9 gives us 63. Sorry, 7 times 9 gives us 63. And you are good to go. Hence, since this is a multiple of 7, we can also say 672 is also a multiple of 7. But if you aren't that good with your multiple, you can still proceed with the rule, right? So proceeding with the rule, we say we have 63. You can still choose to what? Separate your numbers. So you have 6 now and then 3. That is you writing your number as 2 separate what? Numbers. Then let's double this 3 over here. If we double this 3, that is times 2, we get a 6. This new 6 we have gotten, let's take it out of the remaining digit. So 6 minus 6. That gives me a 0. I do hope you know or you've realized what we are doing here. In actual sense now, we want to find out if 63 is divisible by 7. And we have done that. Since we have our 0 here, it says if the result is 0 or a multiple of 7, it means the number is divisible by 7. So we've been able to determine that 63 is actually a multiple of 7. And if 63 here is a multiple of 7, then it also means 672 is also a multiple of 7. As I said earlier on, you could have ended here if you know that 63 is a multiple of 7. Hence, 672 is also a multiple of 7. But if you doubt, you can still continue with the rules, right? Just to be sure. Let's look at our next number, which is 8. So for the rule for 7, 8, it says If the number formed by the last three digits is divisible by 8, then the whole number is divisible by 8. You see, this one is just as the 4, because we actually said for 4, if the last two digits is divisible by 4, then the whole number is divisible by 4. Then for 8, it actually goes a step further. If the last three digits, so it means this rule only works for numbers that are from 3 digits and above. It simply means you need to know all your multiples of 8 that are 2 and then 3 digits, because the rule will only work for 3 digits. So let's take some example and then see. We have 4,168. We want to determine whether or not this number here is divisible by what? 8. So what do? We want to rather confirm if the last three is divisible. You see, so the 168. So you can quickly confirm that with your long division. So we have 168. Then our 8 comes outside. 8 divides 1, 0. Then 8, let me take it to this. So 8 divides 1, 0. Then 8 times 0, we have a 0 there. If we subtract, we have 1. Then we bring our 6 down. 8 divides 16, how many times? Twice. 8 to 16. If we subtract, we have nothing left. Then bring our 8 down. 8 divides 8 once. 8, 1, 8. You subtract, what do you have? Nothing. So it's actually what? A 21, remainder 0. There's actually no remainder, right? So we say that since 8 divides 168 with no remainder, it simply means for 4,168, 8 can also divide it exactly, right? So the rule says that if the last three digits is divisible by 3, then by 8, then it simply means the whole number is also divisible by what? 8. So you can take, let me say 2, 4, 7, 3, 8, 1, 6, 8. You see, so for this rule, it is actually useful for huge numbers, right? If we actually had this number here, which is a 24,738,168. All we need to do is to test for the last three digits. And if it is true, we can say this number here is divisible by 8. We are good to go. Let's look at 9. So for that of 9 here is actually as similar to that of 3, if you had taken note of the 3. It says if the sum of the digits is divisible by 9, then the original number is also divisible by 9. And you remember that of 3, we said if the sum of the digits is divisible by 3, then the original number is also divisible by 3. 9 here says if the sum of the digits is divisible by 9, then the original number is also divisible by 9. So let's take an example. If we have the number 5,184, and we want to determine whether or not it is divisible by what? 9. So we add 5 to 1. 5 plus 1 gives us 6. Then 6 plus 8 gives us a 14. Then 14 plus 4 gives us an 18. You see, so that is 5 plus 1 plus 8 plus 4. You are adding up the digits. 5 plus 1 plus 8 plus 4 gives us an 18. So you ask yourself, the sum we have gotten over here, is it divisible by 9? Yes, we know 9 divides 18 twice with a remainder of 0, hence it is divisible. So if the sum is divisible by 9, then it simply means the original number is also divisible by 9. It is as simple as you see, right? If we sum up the number and the answer we'll get is divisible by 9, straightforward. We do our conclusion, right? Now, that of 10, I do hope it is very obvious for everyone. A number is divisible by 10 if the last digit is 0. And for that reason, we are on our 10th minute. So a number is divisible by 10 if the last digit is 0. Any number that ends in 0, 10 can divide it. So we won't spend much time on it. Let's quickly go to 11, which is our last one. So with 10 done, we say a number is divisible by 11 if we alternate subtracting and then adding the digits from left to right. Though if you do from right to left, you still get the same answer though, but then with a different polarity. That means it will either be negative or a positive. If the result is 0 or a multiple of 11, then the original number is divisible by 11. What does this mean? So let's take a number, and I'll take the number 1331. So what the alternating subtraction and then addition simply means is, if I take my first one, 1, and then I choose to subtract 3, then my next operation should be addition. So add 3. My next operation should be subtraction. Subtract 1. You see? So that 1 minus 3 gives us a negative 2. Negative 2 plus 3 gives us a 1. Then 1 plus 1 gives us 1 minus 1 gives us what? A 0. And the result is 0. You see? And the rule says if the result is 0 or a multiple of 11, it simply means the number is divisible by 11. Straightforward. Okay. So we've gotten 0, and it simply means 1331 is divisible by 11. Let's take this example too. So we have 2717. So what do? We alternate addition and subtraction. So 2 minus 7 plus what? 1, then minus 7. As you have seen, we started with subtraction, addition, and subtraction. We are alternating them. Alternating means if you start with this one, you go to the other. Come to this one, you go to the other. 2 minus 7 gives us a negative 5. Negative 5 plus 1 gives us a negative 4. You see? Now, the negative 4 we have now, it then says minus 11. Minus 11. So it then says minus 7. Right? Minus 7. Sorry about that. Minus 7. So negative 4 minus 7 will give us a negative 11. Let's take it again. So 2 minus 7 gives us negative 5. Negative 5 plus 1 gives us negative 4. Then your negative 4 minus 7 will give you negative 11. This is the negative 11 over here. And negative 11 is actually a multiple of 11. You see? So if we forget about this symbol over here, we get an absolute value of 11. It is a multiple of 11. So it confirms that what? 2717 is a what? A multiple of 11, or 11 divides it without a remainder. That is it for it. So we now know all the major divisibility rules. The rest are just a combination of these smaller ones. For instance, 12 is just the combination of that of 4 and 3. You see, and it goes on and on and on. So I'll end this lesson here, but before I end, as usual, I'll leave an exercise for you to try your hand on. Unlike the previous one where I drew the table, this time around I'll just draw the table. Then you use the rules to determine that for me. So this is the table you have here, and you are just to fill it out. You would ask yourself, for the first number, 203, is it divisible by 7? If it is, you just come and take. If it isn't, you take as well. Then that of 8, you take if it is, and then you also take if it isn't. Right? That is all for this lesson. I do hope it was helpful. If there's any issue of concern, you can always let me know at the comment section. And if this is your first time watching a video on this channel, this is How Beyond Numbers, where we learn maths the easy way. You can always choose to subscribe if you so do wish, so that anytime I release a video, you'll be notified as well. Stay blessed, and bye for now.